As I indicated earlier on the measurement of our hardwood circle, we now have a new engineering tape measure. It's from Pi Tape Corporation. It's a 4-meter tape with millimeter hash marks from the 3000 to the 4000 range, and the rest are at the 1 meter, every 1 meter range up to 3000. This is an NIST, National Institute for Standards and Technology. Essentially the U.S.'s Bureau of Standard Weights and Measures, certified by the NIST. So we're going to be using the new Pi tape measure and remeasure some of our previously drawn and measured drawings for the physical measurement of pi. So first I just wanted to show the entire setup here. This is Math Proof 7. As you can look on the website and see. Don't know if I can zero in on that. Yes, I can. In which we physically measured not only the circumference and the diameter of the circle, we also did the math proof on this same drawing. Since if you remember, we drew the Kepler triangle from a 1, 2, square root of 5 right triangle, and then used the sides of Kepler's golden ratio right triangle to come up with the proof of the true value of pi. One of the first things we want to do in measuring the diameter and the circumference of the circle is show that the table is level. We can zero in on the central bubble there. As you can see, it's level, and we'll move the level another position on the table, and it's still level. Let me move it off the yellow background. You can see it's yellow there. We'll turn it and take a look. Once again, it's still level, and this is good over here. Once again, we can see that the table is level at every position. Let's measure the diameter of the circle. Once again, this is from Math Proof 7 drawing and the math proof. And as you can see, we have the pi tape across the middle to the center to the other end. And I'm going to be using the hash marks in millimeters from the 3000 to the 4000, since they show the individual marks. So you can see the 3000 mark right at the edge of the circle, right on the outside edge, which is what we want to measure, and then move across the diameter to zero in on this. The center, 3500, from 3000 to 3500, and the center, and across to the other edge at the 4000 millimeter mark. So you can see the line is right on the outside edge of the circle, which is exactly where we want it, because we want to measure the circle. Don't want the tape measure to become part of the measurement. So our pi tape shows us that the diameter is exactly 1 meter, or 1000 millimeters. Here's the radius of the big yellow circle that we drew. 3500 at the center. You can see the beam compass pointer. And let's pan over to the edge here. Zero in at our 3000 mark. You see the other end of the beam compass pointing at 3000 millimeters. So that's the radius. Of the compass. Measured against the pi tape, and then we will translate and calibrate that to the circle cutter. Now we're looking at the rotary circle cutter, which I've pushed into the bottom of the foam board. It was calibrated to exactly 500 millimeters, which I'm going to show you. Okay, so there is the circle cutter that we used to cut this entire circle for this physical measurement. So my assistant will pick up the rotary circle cutter. Yes, and let's zero in on the marks that were made. There is where it was sliced in at 2, and the pointer of the circle cutter was at 1. So from 1 to 2, it has been calibrated to 500 millimeters. And my assistant's going to pick up and put the beam compass rather into those holes to show you that from 1 to 2 is indeed the 500 millimeters. Right there is the pointer, and here was the cutter, the blade. The blade was right there. So as you can see, that's what we did. So now I have, excuse me, now I have shown that both the beam compass and the rotary circle cutter were calibrated to the Pi Corporation tape measure. Okay, and so the beam compass, which you can see one end here and the other end here at the center, was used to draw the circle, the big yellow circle, with a diameter of 1 meter, and the circle cutter, which we calibrated as I showed you right here, as I pressed the exacto blade of the circle cutter here and the pointer here and measured it with the beam compass to be exactly 500 millimeters. That goes into 1, and that goes, oops, a little fast there, into 2. Let me get this straighter. So that's the 500 millimeters for the rotary circle cutter. Okay. Now all we have left to do is insert the Pi tape measure into the slot that we've cut around the whole circle with a rotary circle cutter and measure the circumference. And that circumference divided by the 1,000 diameter meter will be pi. So we've wrapped the tape, 4-meter tape, around the outlined yellow circle, and going to measure the Pi circumference. If we turn this around, we get a shot of this tape. We'll set it up to get a good picture here. Zero in on the tape. Let me adjust it. So now we've wrapped the pi tape around the circumference of the circle, and we're going to measure the circumference. Here is the end of the tape right here, and so we're going to tighten it up and measure it. So we have, as you can see, 3,140, 1, 2, 3, 4, and just looking at it, about 0.5, could be 0.6. Not sure what our vernier would show. It shows about actually 0.5 or 6. This would be old pi right here, 3141, and here's the end of the tape, 3144. If you let it go out, 3145, snug it up like it's supposed to be, and clearly we have 3,140 and 4 little millimeter marks, 1, 2, 3, 4, and anywhere from 0.5 to 0.6. That's the circumference.